Rowdy is a cat dad of 5 cats, and he loves Formula One. You kind of can tell about the title shows. So please give an extra loud applause for Rowdy.
Yeah, thank you for that. You thought you were getting Sander here about Scully. This is the only Scully I know. Sorry about that. This is from my childhood, my 20s, in the 1990s, so you know how old I am. And also saw Katerina showing her cats this morning, so I decided, well, we need some purr as well here. So these are mine, but all jokes aside, I have a need for speed, like Formula One, like IndyCar racing, but also for websites. And maybe you have a need for speed as well, for me to get on with it so you can go to lunch. Let's start with some code. I don't start with Angular yet. This is just plain JavaScript, CSS, and HTML. I created this website, and if you look at the setup, it's some styles, some font files, and some images, an app.js that's completely empty now. But I want to run it locally, so I installed a HTTP server. We're going to need that one later as well for Angular, but I'll come to that. So let's talk about service workers. What is a service worker? In basic stuff, it's a JavaScript file, plain and simple. But what it does, that it's in between the browser and the network. So it's more or less like a proxy or a man in the middle. It will intercept all outgoing HTTP requests and respond to it however you build it. It runs in the background in a separate thread, so it's not blocking your website at all. So that's a good thing. But it is scoped for your own website or application. Because it's in a separate thread, it cannot access the page, so it cannot do anything with the DOM of your website. It's asynchronous, so you need to use promises or async await. And the most important thing is that it's event-driven. And we see a lot of events coming in the next slides. So I created a sw.js file, a service worker JavaScript file. For now with only 2 events, the install event and the activate event. Install event, well, that's when the service worker is available and will be installed in the browser of the user, and activate is the next step. Then my app.js was empty at first, but I'm now going to try and register the service worker. Most of us are using modern browsers, but we check whether service worker is supported. So that's the first if statement. And we wait until the whole page is loaded before we register the service worker. And this is how that will look. If I refresh the page, you can see there's a service worker file there, and go to the application, and I have a service worker version 0. That's all fun and games, but it doesn't do anything yet. Let's start caching some data. And let's start caching data that we know for sure will be needed, maybe on every page, but at least on the first page. A good practice is to give your static cache a version number. So I used static v1 here. Then I have an array of files that I for sure want to have in my cache available. In this case, the first indexed HTML page, a fav icon, and some assets like CSS and an image and a JavaScript. Never, ever, ever put your service worker JavaScript file on this, because you're doomed. You'll never be able to update it again. Then at the install event, I'm going to open the static cache if it's available and add stuff, or otherwise I'll create a new one and I will add all these files to it. And I set self.skip waiting here, because usually if you create a new service worker, either the user needs to come back a second time to the website, or has to hit refresh to be able to get the most benefit out of the service worker. So if you do this, it's already available for the user to be used. With one extra step I'll show here, is that it's all ready for the user then, but you want to make sure that the page is reloaded. So in this case, if the service worker is installed, I ask the user if he wants to use the new version. And this is how it works. We refresh the page again. And you can see service worker 1 is now there. We get the message and saying OK, and the page is refreshed. And if I go to the cache storage now, I have a v1 there with the files mentioned in that array. Great, we have saved those files to the browser of the user, but we don't do anything with it yet. So let's go and try and fetch that cache data as well. For that, we need to introduce a new event listener in the service worker file, and that's called fetch. And what this code do is it will look to all the caches available, and when the URL of the request matches the one in the cache, it will serve that one from the cache in the browser. Otherwise, the last statement, it will just get it from the network. And let's demo that again. Refreshing the page, getting a new service worker, hitting OK to make sure it's refreshed. And if you look at the size column now, it's all set service worker. This means that it's all loaded from the browser's cache in 12 milliseconds. I'm running this locally, so it's fast anyway, but imagine you're maybe on a train with a spotty Wi-Fi connection. It's really nice for your users to have that instant data coming to them, even though it's maybe not all of the application or the website, but at least they see something, and it's not like waiting for a wide screen to become something useful. But what if the user is offline or has that spotty connection? If we look now, if I go to the second page I have here, with images, it works fine. I get 6 images from the movie, and because I'm online. But what if I go offline? If I go to the page then, well, this page still works because it's in the service worker. But if I go to the next page, like, sorry, not available, we don't have a connection. That's not really a good experience, right? We can do better. So we create something called an offline fallback. This offline fallback is a plain HTML file just saying, well, sorry, hasn't been cached yet. Try some of our other pages. To be able to have this one working, we have to change the service worker again. I add the offline HTML file to the array of static files because I want to have that one available always up front. And as I said, a good measure is to update the version number. So I'm getting here static v2. Next step in the service worker, well, there's static v2. Next step in the service worker is to make sure that if the request to the network fails, I serve that offline HTML page. And this is the way how you can do it. I try to fetch it, but I have a .catch in there to make sure that if something goes wrong, I can do something else. And in this case, I will open the static cache again and serve that offline HTML page to it. But imagine, well, you probably know as well, a page is not only HTML. It's also maybe some extra JavaScript or images or font files or whatever. So we don't want to ship that offline HTML reply every time something goes wrong. So we will check whether the request is for a text HTML header. So only serve this when an HTML is loaded, not for an image or a font file, for instance. And let's look at that as well. Again, we refresh to get a new service worker. There we get service worker 3. Refresh the page so the cache is updated. And now you can see we have a cache for static v1 and a static v2. The difference is in v2 we have the offline HTML there. If I go offline now and go to the stills page, you can see, well, you don't see the images, but you don't get a weird browser error saying, well, go do something for yourself. It's like there's a way out for the user. We now have cached all that static data that we know upfront will be necessary for the page to load. But there are probably more pages in your website that are not that necessarily need to be cached upfront, but when you get there, it's nice to have them cached as well for the next time. So let's introduce dynamic cache. For that, I again set a const with a version number for it, dynamic v1 in this case. You can name it any way you like. And now in my service worker, I change a little bit in the fetch event. We had that catch already for when you're offline, but we now use a .then to use that reply from the network to save to our static cache. So it will get that result of that request. It opens the dynamic cache and will put the result of that network call into the dynamic cache. One thing you need to be aware of is that I clone the response of the network call, because you can only use it once. So if I wouldn't clone it and just put it in the cache, I could not serve it to the browser anymore. Of course, we can see that as well. So we refresh the page, get a new service worker again, number 4. We refresh the page. And now we will go to the stills page again. We're online, so we see the images, but look at the cache storage now. We have still static v1 and v2, but also now the dynamic one with 5 images and the HTML file, because image 1 we already had. If I go offline now, and I will refresh the page, it works. It's all coming from the service worker. And also, of course, the home page still works from the static files, and the next page is also working. So even if the user has a very bad connection or is offline for maybe even 10 seconds, you can serve them the website. You saw we had a static v1 and a static v2. It can be very tricky because we're not really sure which one of the static cache the service worker will use. So let's make sure we only have one static cache, and that should be the latest one, right? So for this, in the activate event, we will open all the caches and check whether the key of that cache matches our version number. We do that for the static cache and for the dynamic cache. And if it doesn't match, just delete it. So simple example here, of course, when we reload again, get a new service worker, the page will be reloaded, and if you look at the cache storage, v1 is gone now. So we know for sure that the proper cache is used by the browser. We are at an Angular conference. So let's see how you can do that in Angular. You know the basics now, and I must say Angular has a much easier way for you to do that. You don't have to write a lot of code. I created the same page in Angular, switched the colors, yellow background now, so you know that it's a different one. And if you look at the setup, it's just a plain ng create with some extra components for the home and the stills. And I made sure that I have an assets folder with the font files and the images. And of course, I have my CSS as well. So I didn't change a lot to the basic stuff you get from ng-create. Angular has a proper package for it, a dependency you can install. If you use ng-add Angular/pwa, it will ask for you, well, do you want to proceed? Of course, we want to have that pwa package, and it will create a few files for you. ngsw-config, that's an important one. It will also create a manifest file. I will explain a little bit later what that means. It will generate icons as well, and it will update your package.json, your Angular.json, and your app module, and your index.html. So it does a lot of things for you already. As mentioned, it adds that package to your project. It also makes sure that the CLI knows how to build your app as a PWA using the service workers. And as I said, it imports and registers the service worker already for you. You don't have to do anything for you and the config file. It does some extra things for PWA support. If you want to make your app installable on a phone, for instance, to have an icon on the home on the homepage of your screen, on your home screen, then you can use the things that are generated for you for this. But this is all about service workers, so I'm going to leave it like this. Now, if you look at your app module, all the gray stuff was generated with ng-create. But the service worker install made sure that in the import of your ng module, for instance, as I said, it's registered, and it will be it will wait until your application is a little bit stable, or 30 seconds, and make sure that it's ready to go. This is the most interesting part. This is your config file. You can see you have asset groups with resources, and let's dive a little bit deeper in this. An asset group defines the resources you want to cache. You have an install mode. Install mode you can set to prefetch or lazy. The install mode is the initial cache of your app. So the first time you deploy Angular PWA with service workers. Prefetch means give me all the files immediately. Download and cache it. Lazy is only when you're coming across. So like the dynamic cache we had in the, say, the plain example. The update mode is working the same way, but when you're updating to a new version of your Angular PWA with service workers. Keep in mind, if you want to use lazy in update mode, it's only available to use when it's also lazy in install mode. At the part where you have resources and files, files are always files from your dist folder. You can use exact path there, or just a pattern, say, well, just all JavaScript files or all HTML files, for instance. You can also include URLs. So if you have a dependency on a CDN or Google Fonts or something, you can add them as well. But they will be cached at runtime. And something extra you can do if you don't want to have things cached that are having some query strings in URL, you can set this to false as well. Another interesting thing that I'm not using here is the data group. And the data group you will use for API calls. So if you get a bunch of JSON back with, I don't know, to-do lists or users or avatars or whatever, you use the data group for this. And you can define absolute URLs again, but also patterns. And the nice thing is you can set also a max amount of cache responses that will be saved to the browser cache, because you don't want to bloat the whole storage of the user in the browser. You can also set cache invalidation. So let's say we only want to store these JSON responses for 7 days, and just after that they might be not fresh anymore, so get rid of them. And a caching strategy, freshness and performance. Freshness means always get them from the network first, and if that fails for some reason or takes too long, then serve them from the cache. And performance means serve them as soon as you can from the cache, and maybe later on use them from the network if they are fresher. Sorry. What I added on the ng on init here is I want to have the same interaction with the user, saying, well, there's a new version available. Do you want to reload it? So that's what I did here. In my package.json, you can see there's a new dependency there that I added manually, because if you're developing this locally, you can't use ng-serve. The PWA, the service worker, won't work, so you need to have a different server running for that. So you can use the HTTP server again. Enough talk, let's see how that works. You see there's a service worker. It takes a little bit more time, maybe those 30 seconds as well, later on. But you see, things are being cached in a different version number or name that we do. And if you go offline, if we refresh, you can see, well, okay, it kind of works. Image is not loaded, this page as well, and the font for my headings isn't loaded as well. And that's because we had only defined some files to be cached. So can we do something like an offline fallback? Well, not really. But what we can do is prefetch all those images, font files, CSS, and whatever as well. And if we do that and refresh the page, and now we will get that banner again saying, well, there's a new version. There it is. So it will refresh the page again. We go offline. Do a refresh again. You can see everything is working. If we go to the stills, all the images are there as well. I'm not sure if this is a good way to do it, to fetch everything up front, because if you have a very large application, I'm not sure the user likes it when you take a lot of bandwidth from their data plan, for instance. So try to keep a balance in that. And with that, I want to say thank you. You can find all the slides, all the links to the GitHub branches that were mentioned on the left bottom. You can find them all there. And I hope you enjoy the rest of your day, and in a few minutes your lunch as well. So thank you.